Hey, Danya, so this is the last one. Okay, aren't you excited? So you've already got all the limits stuff, and this is the last assignment or last lesson that's left on the trig stuff that regular Math 3 did not get exposed to. So here we go, let's dive right in. So we need to find all solutions. So I wanna highlight that. So all possible solutions where x, the angle, is between 0 and 2 pi, okay? So anything between 0 and 2 pi. So that means between a full rotation. So we're looking at anywhere on the unit circle where this is possible, okay? So since we're talking unit circle, we need a little bit of some practice and put in the unit circle here. So I'm gonna try to draw a nice circle. Oh, well, that sucked, but whatever. And try to use those lines to help me, okay? And then I need 3 lines, 3 lines, 3 lines, 3 lines, okay? And I know that this goes, I'm just gonna put the radians in here instead of the degrees, or both, not instead of, but instead of doing both, I'm gonna put just the radians. So this is pi over 6, pi over 4, pi over 3, pi over 2, 2 pi over 3, 3 pi over 4, 5 pi over 6, 7 pi over 6, 5 pi over 4, try not to look this time, 2 pi over 3, 4 pi over 3, this one is 3 pi over 2, and then this is the 300-degree angle. That's 5 pi over 3, and then 7 pi over 4, and then 11 pi over 6. I know I wrote that really small, but I said it out loud, so hopefully that's enough. I don't know. Okay, so we have coordinates 1, 0. Square root of 3 over 2, 1/2. Why is this freaking out? Nick, can you turn on the light in here? Because I think it's freaking out because it can't focus because it's getting too dark. Square root of 2 over 2. It's in the afternoon now. Oh, whoa, that's really bright. I guess I've been sitting in the dark for a long time. 1/2 square root of 3 over 2. And then this is 0, 1. And got distracted by some messages from Instagram. Anyways, so this is negative 1/2 square root of 3 over 2, negative square root of 2 over 2, square root of 2 over 2, negative square root of 3 over 2, 1/2, I don't know what I was doing. This one, both are negative, so negative square root of 3 over 2, negative 1/2. Negative square root of 2 over 2, negative square root of 2 over 2, negative 1/2, negative square root of 3 over 2, and then this one is the point 0, negative 1, this point right here, and then this one is pi over 3, so it's a 1/2, negative square root of 3 over 2, square root of 2 over 2, negative square root of 2 over 2, and then this one is square root of 3 over 2, negative 1/2. Okay, so have my unit circle. You'll be happy that you have that there because it'll be right there when you need to answer some of these questions and you need it. So you'll be really happy about that. Okay, so cosine of x minus the square root of 2 over 2 equals 0. We're solving trig equations. So that means that we're going to need to solve for x, just like you would in a normal algebra 1 type of equation. So I'm gonna add the square root of 2 over 2 to both sides. That way we get rid of it on the left and now it's over on the right. And so I will have cosine of x equals square root of 2 over 2. It's positive now because we added it to the other side. Okay, so the question is, where on the circle is this? Okay. Well, between 0 and 2 pi means a full rotation around our unit circle, And the cosine is a positive square root of 2 over 2 at pi over 4. It's negative here, and at 7 pi over 4. So those are the two possibilities. So that would be x equals pi over 4 and 7 pi over 4. Another reason why I didn't put degrees is, remember how we keep these in radians? So I don't need the degrees anyway. So why put them on there if I don't need them? Don't do the extra unless you have to. Okay, so next one, sine of x plus the square root of 2 equals negative sine x. So since I have sine of x on both sides, I'm going to add this one. Let's combine like terms. So those cancel. Sine of x plus sine of x is 2 sine x plus square root of 2 equals 0. Subtract the square root of 2 from both sides, so on the other side it'll be negative square root of 2. And let's solve for sine x. So that means we would divide 2 on both sides to get rid of that 2 in the front. So sine of x would equal negative square root of 2 over 2. Another term or another number that we see on our unit circle. Where is this on our unit circle? Sine is negative. Okay, negative square root of 2 over 2. So sine would be negative right here. So that's at 5 pi over 4. And sine is also a negative square root of 2 over 2 right here at 7 pi over 4. So 5 pi over 4 and 7 pi over 4. So x equals 5 pi over 4 and 7 pi over 4. Okay, number 3, cotangent of x times cosine squared of x equals 2 cotangent x. Okay, so what we're going to do is we're going to factor out something. Hold on, I can't even understand my own handwriting. Oh, that's because I didn't write it right. Okay, so sorry. Sorry. Okay. So what we're going to do is we're going to get this to equal 0 because we've got a lot going on, but I know that both of these have at least a cotangent x. So I'm going to subtract 2 cotangent x from both sides. And I'm going to fix that on my worksheet here because that was wrong. Okay, so we're going to have cotangent x cosine squared x minus 2 cotangent x equals 0. Okay. Well, there is a cotangent in common, like I mentioned a second ago. So let's go ahead and factor that out. So we're going to factor here. So I'm going to write that in just to remind you later so that when you look at these later, if you do look at them later, that's what you did. So let's take the cotangent x out. So divide it out. Cotangent x cosine squared x divided by cotangent x leaves me with cosine squared x. Negative 2 cotangent x divided by cotangent x leaves me with just a negative 2. Okay. All right, now I have 2 factors and they're set equal to 0. So now I can use the zero product property, which we learned back in Math 1, and we did this again in Math 2. That's where you take these factors, break them apart, and set them each equal to 0. So we're going to have the cotangent of x equals 0 and the cosine squared of x minus 2 equals 0. Okay. And remember, cotangent is the same as cosine over sine. So we're basically saying, where does the cosine over sine equal 0? Okay. So that means that the numerator has to be 0. Because that's the only number that we would be able to get this on the unit circle. So the cosine would have to be a 0. So it's got to be either pi over 2 or negative pi over 2, because 0 divided by negative 1 is 0, and 0 divided by positive 1 is 0. So I'm getting 2 possibilities for just this one. So x could equal pi over 2 or 3 pi over 2. So those are those two possibilities. Now let's solve the other one. So I would have to add 2 to both sides, and I would get cosine squared x equals 2. And then I have to undo the square, so I have to square root both sides. Didn't think you could do that now, did ya? And we will get cosine of x equals plus or minus the square root of 2. Okay, so the reason why I have the plus or minus is because I need to figure out what works. And so that means that x must be the cosine inverse of plus or minus square root of 2. Well, for the cosine to be square root of 2, cosine is never just the square root of 2 on the unit circle. So that means it would be off the unit circle, which means I need to try to type this into my calculator. So I need my calculator to be in radians, remember? So I have to switch that back. And I'm going to hit cosine inverse, so second cosine of the square. I'm going to try the positive square root of 2. Error. Oh, so that means that there's no angle there. It's error, undefined. Okay, let's try negative square root of 2. Domain error. So because of that, I'm getting error. So there's nothing out of that. So my only two answers are the two that I got from the first factor, which is pi over 2 and 3 pi over 2. Okay, so that was 3. Number 4 is the sine of 2x equals negative cosine x. So this is where you have to recall the last set of notes that we just did, the double angle identity. And we had just learned that sine of 2 theta equals 2 sine theta cosine theta. So let's write that. So this is 2 sine theta cosine theta, sorry. X instead of theta, because that's the variable they're using here. Oh, shoot, that's supposed to be an x. I said it and I still wrote theta. Okay, so let's get the cosine of x on the other side because they'll both have a cosine x. So that means I would have to add it to both sides. So I would get 2 sine x cosine x plus this one and then equals 0 because there'll be nothing left on the right side there. Okay, so since they both have something in common, this cosine of x, let's factor it out. So I'll factor it out front. And when I divide that out, I will have 2 sine x left plus cosine divided by itself is 1. So 2 sine x plus 1 equals 0. And now I have two factors, so I could do what I did up above, set each of these factors equal to 0. So I will have cosine of x equals 0 and 2 sine x plus 1 equals 0. So for this one, where on the unit circle is the cosine 0? Well, cosine is 0 in 2 spots. Oh, I forgot to put the other one right here. This one should be -1, 0. The cosine is 0 at pi over 2 and at 3 pi over 2. Okay, so that's the answer to that one. So x equals pi over 2 and 3 pi over 2. And honestly, we should know that since that was the answer to the last problem. So there's that. And this one, let's go ahead and solve. So we have to subtract 1 on both sides. We'll get 2 sine x equals -1. Divide both sides by 2. We'll get the sine of x equals basically -1/2. Okay, where on the unit circle is the sine a -1/2? Well, sine is a -1/2 at 7 pi over 6. And at 11 pi over 6. So that means that x could also equal 7 pi over 6 and 11 pi over 6. So notice it's not going to do exactly the same that happened in number 3. You know how we got an error for the other factor? So we could get 2, we could get 4, we could get 1. Like well, actually we probably wouldn't get 1. It'd probably be 2 or 4. Okay. All right, so that was number 4. Okay, the next one, number 5, 9 sine x minus 1 equals sine x plus 2. So since I have a sine x on each side, I'm going to get them all together. And this one's positive, so that means I'm going to have to subtract. So I will get 8 sine x minus 1 equals 2. And let's start solving. So I would add 1 to both sides. So I would get 8 sine x equals 3. And then I would have to divide by 8 on both sides. So I would get sine of x equals 3 over 8, 3/8. Okay, well, this is definitely not on the unit circle. This is off the circle. So we have to use another method to solve it, which means we have to use a reference triangle. Okay, so we have to use a graph. Okay, so remember that sine is positive. This is a positive 3/8. So where is the sign positive? Sine is positive in the first quadrant and the second quadrant only. It's negative in the third and fourth. So that means I'm going to have a reference triangle here and a reference triangle here. Okay, so for this one, I'm going to find the first angle, and I can use my calculator. I'm going to change colors here. Where's my purple pen? I want purple. So I can find x by taking the sine inverse of the ratio 3/8. That's going to be what x is. So I need my calculator for that. And remember, this is going to be in radians. It's not going to be in degrees, and I'm already in radian mode in my calculator. So second sine of 3/8 is 0.38. So x is approximately 0.38. Okay, so this is the smallest one. So remember how it starts at 0 radians and then it works its way over? Pi, how many radians is pi? 3.14, obviously, pi is 3.14. So 0.38 is this one over here. So this angle opens up at 0.38 radians. But 0.38 is also the reference, so that means this one opens up this way an amount of 0.38 radians. But if I know that this is 3.14, it's pi, I just have to take pi and subtract 0.38. So that means I'm going to have to take that away. So I'm literally going to hit pi minus 0.38. And I get that the second one is 2.76. So x equals 0.38 and 2.76. Okay. All right, that was 5. Number 6, sine of x plus cosine of x equals 1. So this one we have to kind of think outside the box. Okay, so why did I do it that way? Okay, there's many different ways to do this problem. So I'm like trying to figure out why I did it the way that I did it on my notes, but this is the way that I want to do it. Okay, so what we're going to do is we're going to go ahead and separate the sine and the cosine. So I'm going to subtract cosine from both sides. And I'm being strategic here because I want to separate them so that I can square them if I need to, which I will need to. So I'm going to get 1 minus cosine of x, okay? And I want to square both sides because I know that when I square sine or cosine, I can get an identity out of that somehow. So I'm going to square both sides. So I'll use a different color to show that that's a new step. So this is squared and this is squared, okay? And on this side, I'm going to need to multiply that out. So kind of off to the side, I'm going to 1 minus cosine squared is 1 minus cosine x times 1 minus cosine x. I'm just trying to squeeze that in there. Okay. So this is going to be 1 times 1 is 1 minus cosine x, so that's minus 2 cosine x. And then negative cosine x times negative cosine x is positive cosine squared x. And the sine squared x, well, sine squared, remember our identity? Sine squared plus cosine squared equals 1. Well, sine squared is the same as if I subtract cosine squared. It would be 1 minus cosine squared. And the reason why I changed that is because of all these cosines over here. I want everything to be in terms of cosine. Okay, so let's get everything over to one side, because if we have a degree 2, if it were like a parabola or something, we would want to get everything to one side of the equation and 0 on the other. So I'm going to subtract 1 from both sides, but I want you to notice, when I subtract 1 from both sides, they're both going to go away. I'm going to add cosine squared to both sides, so I'm going to have 0 equals negative 2 cosine x plus, I'm going to have cosine squared x plus I'm adding this cosine squared x, so I'm going to have 2 cosine squared x. Okay, and I have 2 terms, and I can totally factor this. Okay, they both have a 2 cosine x. So I'm going to factor out a 2 cosine x. So I'm going to have negative 1 plus cosine x. Okay, and then I can separate those 2 factors like we've learned. So I'm just going to kind of squeeze that in here. So I'm going to switch colors to show that something changed. Where did my pink? There it is. Okay, so I'm going to have, I'll put it over here. So I'm going to have 2 cosine x equals 0. When I divide both sides by 2, 0 divided by 2 is 0. So I have cosine of x equals 0. And we know that when that happens, that x is going to equal pi over 2 and 3 pi over 2, because this will be the third question where this comes up. Okay. The other factor, put it over here, would be, I'm just going to switch it around to cosine x minus 1 equals 0. Add 1 to both sides, and cosine of x equals 1. Well, where does the cosine equal 1? There's only one spot where cosine equals 1, and that's right here at 0 radians. So, comma 0. So x is going to equal all those things. Okay. At some point, I forgot to continue highlighting them, so, oh well. Okay, what color do I want to use? No, we'll use this teal one. Okay. All right, number 7, sine squared x plus cosine x equals 0. So I want to do it again. Let's get everything in terms of cosine. I know that I can switch out sine squared with 1 minus cosine squared. Equals 0. And I want to put this in standard form. So I'm going to have, I'll put the, actually, before I put it in standard form, I want the squared term to be positive, so I want to add it to the other side. So I'm going to move everything over to the other side. So when I do that, everything's going to have its opposite sign. And this is the leading term because it's squared. So on the other side, it'll be positive cosine squared. This one will be negative cosine x, and that will be minus 1. Okay? And we can't factor this, but we can use the quadratic formula. And the quadratic formula is where we have to identify the ABCs. And the leading coefficient, the A value on the cosine squared is an invisible 1. The leading coefficient on the cosine x is a negative 1. And the C value is a negative 1. So instead of x equals negative b, it's going to be cosine of x because this is cosine. So cosine of x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Oops, sorry. Okay, so double negative. I have another double negative, and there we go. You know, I'm going to switch to this teal pen because I don't want it to merge with this work. Okay, so this is going to be cosine of x equals, that's a positive 1 plus or minus square root of, that's 1 plus 4, which is 5, all over 2. Okay, so I have two things that I need to try here. I need to try to solve for x, so I would have cosine inverse of this. I'll have 1 plus square root of 5 all over 2. And I need to try the cosine inverse of 1 minus square root of 5 over 2. So, because this is obviously not on the unit circle. So, let's try it out. Still in radians, second cosine of 1 plus the square root of 5. You know what, it has to be all over 2, so I'm going to back up here. I need it to make sure that when I put all over 2, it divides the 1 plus the square root of 5 by 2, not just the square root of 5 by 2. So I need to put parentheses around that as well. So 1 plus the square root of 5. So that has parentheses around it, and then divide by 2 so that the 2 goes into that whole quantity and not just the square root of 5. And then close the parentheses on the cosine inverse, and I get domain error. So that's not going to be an answer. Let's try the other one. So that would be cosine inverse of, instead of 1 plus, it would be 1 minus. So that's the only thing I'm going to change, hit equals, and I get a number. So x is going to be approximately, let's round it to the nearest hundredth, so that would be 2.24. 2.24, okay? And remember that we're on the whole unit circle from 0 to 2 pi. So 2.24, well, we know that pi is 3.14. So the 2.24 must be in here, okay? And cosine is, cosine is going to be negative, yeah. Because look at what this is. 1 minus the square root of 5, and then divide by 2 is negative, okay? So this is a negative number. So that means this cosine is negative, and cosine is negative in these two quadrants. So we're going to have a reference triangle here and a reference triangle here, and we have to figure out those angles. Well, the 2.241 must be this one, this angle that opens up, okay? So the other one must be the one that goes down here, okay? And that angle, well, I need to figure out, well, how far away is this from 3.14? Well, I know that this is 2.24, so I'm going to take 3.14 and subtract 2.24, and I get 0.90. So this is 0.90. So that means that this opens up 0.90 away from pi. So I'm just going to type in pi plus 0.90, and I get 4.04. So the other angle that it could possibly be is 4.04 radians. Okay, so those get a little tricky, but they're not too bad. All right, so that is all the notes for this. So go ahead and press pause and get started on the homework, which is this assignment right here. Okay, and yeah, I'm gonna go over it right now though. So if you don't press pause, here we go. All right, so we're gonna solve each where 0 is less than or equal to x is less than or equal to 2 pi. Okay, and number 1, we have the tangent of x plus the square root of 3 equals 0. So I'm going to solve for tangent of x. So I'm going to subtract square root of 3 from both sides, and I would get tangent of x equals negative square root of 3. Now we know, based on previous experience, that this can happen on our unit circle. Tangent is sine divided by cosine, so that means that the sine would have to be the square root of 3 over 2, or a negative square root of 3 over 2. And then the cosine would have to be the 1/2, that way the 2's cancel when you dividing fractions easy as pi, flip the second and multiply. So it would have to be a pi over 3 type of angle. But where on the unit circle is one or the other a negative? Well, where's our unit circle? Sine is a negative square root of 3 over 2 right here, but they're both negative there, and that wouldn't give me a negative square root of 3, because a negative divided by negative is positive, so it's not that one. Sine is a positive square root of 3 over 2 here, and cosine is a negative 1/2, and sine over cosine, positive divided by negative, that would give me the negative, and that would give me a square root of 3 answer. So 2 pi over 3 is one of them. Can't be this one because they're both positive. There's no way I would get a negative. So my only other option is this last one, 5 pi over 3. So 2 pi over 3 and 5 pi over 3 are the answers there. So x equals 2 pi over 3 and 5 pi over 3. Okay. All right, number 2, we're going to solve for sine x. So I'm going to add 1 to both sides. To sine x equals 1, divide by 2, I'm going to get the sine of x equals 1/2. That is also on our unit circle. So where on the unit circle is the sine, a positive 1/2? That would be right here at pi over 6, and right here at 5 pi over 6. So x equals pi over 6 and 5 pi over 6. Okay, number 3. Okay, so I see sine on both sides, so I'm going to want to get them to be together. So I'm going to subtract the smaller one, which is the 4 sine x. So I will get 3 sine x plus 2 equals 0. And start solving for sine x. So I would subtract 2 on both sides. So I would get 3 sine x equals negative 2. Divide both sides by 3, and I would get sine of x equals negative 2/3. Okay, so this is obviously off the circle. So I'm going to take an inverse sine, and that will help me find one of them, and then I'll have to find the hidden one. So I'm going to take a sine inverse of negative 2/3. So second sine of negative 2 over 3 is what I have just typed in. And I get negative 0.72. Well, 0.73. Okay, so negative 0.73. So, okay, where is this supposed to be? This is sine, and the sine is negative. Where is sine negative on the unit circle? Sine is negative in the 3rd and 4th quadrant. So I'm here or here, okay? So negative 0.72 or 0.73 means I'm going in this direction by 0.73. Okay, well, actually, negative 0.73. So remember, a full rotation would be at 2 pi. So if I'm going backwards, I would have to subtract 0.73 from 2 pi to figure out how many radians this whole thing is all the way around that way. So 2 pi minus 0.73 is 5.55. So that's one of them. The other one is also going to be a reference of 0.73 away in this direction. But to know the angle that goes from here and stops there, that's going to be pi plus the 0.73. So pi plus 0.73 is 3.87. Okay. Number 4, I have 4 sine squared x minus 8 cosine x plus 1 equals 0. So this one gets a little tricky because you have to use some identities. So first of all, we need to have the same thing. We need both sine squareds or both cosine x. So I do know that sine squared is the same as 1 minus cosine squared. Remember that from the notes that we just did? So I'm going to use that to my advantage. So I'm going to replace the sine squared x with 1 minus cosine squared x, because then I'll have everything in terms of cosine. Okay, So I'm going to have, when I distribute the 4 minus 4 cosine squared x minus 8 cosine x